right? So as the name is saying, what is intermolecular forces? Is the forces between the molecule, right? The name is saying intermolecular, right? So there are three kind of forces or three kind of intermolecular forces that you need to mainly focus on this chapter. So let me tell you what are those three. First one is called dispersion force, right? So we're going to learn what is dispersion force. Second is dipole forces or dipole attraction, right? This is our second force. And the third force is hydrogen bonding. So you have to remember all these three names. If I ask you what are the three different type of intermolecular forces, you have to name them, right, or pick the right answer. So now let's get back to the first intermolecular forces, which is dispersion force. What is dispersion force? We have so before we go on the dispersion force, you have to know that we have some synonyms for this dispersion forces. We have London forces, sometimes we call it instantaneous dipole, right? And let's see what is this dispersion force mean. Right, let me show you over here. Let's say you have two atoms. What you have inside the atom? You have electrons revolving, right, around the nucleus. You have electron, right? So the electrons are keep on revolving around the nucleus, right? This is atom A, atom B. So there is a some time or instantaneous fraction of time, you can say, where most of the electrons are placed on one side of the atom, right? There is a time because they are keep on moving around the nucleus, right? And then you will see this electron is moving this way. This electron after some time is gonna move this way, right? So the fraction of time, this two electron is on the right hand side of the nucleus, and on atom A, the two other electron is on the left side of the atom, right? And after couple of second or millisecond after, this electron is going to move it again over here. So this keep on moving, right? But what happen if these two electron from same atom goes to one side? It makes this side a negative charge because you have more number of electron on one side, right? And because all of the electron or most of the electron is on this side become a little bit positive because you have less electron at that particular time, right? Similarly over here on this side, electron is over here, so this side will become negative and this side will become positive. Or let me change this one because we need. So let's move this electron over here, right? It's moving there, so this will become positive and this will become negative, right? So because of this instantaneous making of this positive and negative charge on both the atom, the opposite charge will attract each other, right? And because of this, these two atoms can come close to the together and make a force of attraction, which is called dispersion force, right? And after some time, the electron is going to move it back again this side, and then these two electron is going to move it on this side. Now what's going to happen? This positive will going to change into a negative sign, right? And this will become positive because electron is now on the other side. Everyone getting this thing? So after every millisecond, after fraction of second, the electrons keep on changing and then keep on changing the positive and negative side within the atom, right? That's why this is also called instantaneous dipole force. Instantaneous dipole force. We know instantaneous means at random, right? Very fast changing thing. What is dipole mean? Dipole, if you already know in polar molecule, when we did the chemical bonding, dipoles means whenever within the molecule, if you have positive and negative charge, this is one dipole. This is positive and negative charge. This is second dipole, two poles within the same molecule. And the force of attraction between the two dipole, we call as dipole interaction. right? So that's why it's called instantaneous dipole forces, because you're changing plus negative, right? Positive negative, right? So that's why we have different name for dispersion forces, right? And then where you can think of this dispersion force can be present, which kind of molecule can show dispersion forces? Polar molecule or non-polar molecule? Can you give me the answer? Which kind of molecule can show these forces? I'm giving you two options: polar molecule or non-polar molecule. Anyone from the class wants to just take a random guess? Polar or non-polar? So this kind of forces, make sure you remember, this kind of forces is present for every molecule. It doesn't depend on being polar or being non-polar, because every atom has an electron inside them, right? As long as you have the electron is keep on moving, you will getting instantaneous dipole every time, right? So this kind of force is present everywhere. Remember this thing, right? Doesn't matter if the molecule is polar or non-polar, right? So this we call as instantaneous dipole forces. So you have to remember all these three names: London forces, instantaneous dipole, or dispersion forces. They are same. So everything is already explained over here. So now let's go to the next slide, or next force, which is called dipole force, right? So what is dipole force? Let me tell you over here. So let's say if you have, let me show you in the next thing over here. Second is dipole force, right? Dipole force, right? So that means you should have two dipole to make this kind of forces, right? And then if we need two dipole, can you tell me which kind of molecule can show this kind of forces? Only polar molecule, because non-polar cannot have a dipole moment, right? So remember this thing, only polar molecule can show this dipole force. Let's see what is dipole force. Let's take one example: water. The structure of water is this, if you remember from chemical bonding. H, oxygen, H, right? So this is the structure of water. And then we already know in this water molecule, this is partially negative charge. Hydrogen is partially positive charge. This is same again. This is negative charge. This is positive charge. Hydrogen is positive because hydrogen is less electronegative. Negative charge, positive charge, right? So within this, if you have a glass of water, we have too many molecule of H2O water in there, right? When they come close together, you will have some force of attraction. If you can see, the negative charge from this water interact with hydrogen from another water molecule, right? Same thing happen over here. You can get positive and negative, right? Getting, and then you can have same thing over here, negative and positive, right? You can have this thing, negative and positive. So you have a cluster of bonding, right? Why is called dipole forces? Because less, let me see. If you see this molecule of water, what is this? One of the bond from this molecule, O and H, negative and positive. This is one dipole, right? What is this from the second molecule? If I say just this bond, this is second dipole. This is one dipole. And what's this force of attraction? Is between dipole 1 and dipole 2, right? So it's dipole attraction. Same thing happening between this over here. This is dipole 3 from the third molecule, and then this is also dipole, right? The second bond. So it's dipole-dipole attraction. There's dotted yellow line, right? What about the third force? It's called hydrogen bond. So what is hydrogen bond? So if you have any three atom, nitrogen, oxygen, and fluorine, you have, if you have three atom and this atom is attached with the hydrogen, then these hydrogen, these molecule can form hydrogen bonds. So you have to remember these three atom, nitrogen, oxygen, and fluorine. Let me give you one example over here. Let's say hydrogen fluoride, H, F, right? And then let's say F, H. I just write it down opposite way. So if you know fluorine is more electronegative, hydrogen is less electronegative, and then it's become negative charge, hydrogen is positive charge. Same thing again, fluorine is negative charge, hydrogen is positive charge. So it's a dipole. This is one dipole. This is second dipole, right? And then if you have a dipole, then I can say this negative attract with the positive, this negative attack with the this positive. So this is called dipole-dipole force. Oh, this called hydrogen bond, right? Can we say this kind of force that I drew in the dotted green like structure as a dipole-dipole force too? Why? Because it's still a attraction between two dipole. So I can say hydrogen bond is a type of dipole-dipole interaction, right? So how you can differentiate dipole-dipole and hydrogen bond? So remember, if the hydrogen is present or attached with any of these three atoms, nitrogen, oxygen, and fluorine. So basically we have two kind of force of attraction, dipole-dipole as well as hydrogen bond, right? You can pick any of these, hydrogen bond or dipole-dipole, right? Even though we say is hydrogen bond is not a real bond, is just the name, because there is no sharing of electron between hydrogen and fluorine in this case, right? And it's just a opposite charge attraction, positive and negative